Okay, we're now going to talk about analytics for enabling business strategy. So what is analytics? Originally in our business, which would be more sort of using mathematics and computers for business problem solving, it was operations research, but it was very much focused on operations. Then later on we called it management science because we were focusing on more of the management of people and not just operations. But recently it's moved into more strategic things, into using technical and structural analysis of complex problems, and using technology, using IT, using software. So I want to show today two illustrations of this. One is to use the structures within decision making for a medical application to diagnose dementia. And the other one is in sport, in rugby, to show how you can gather together all the data and all the expertise about rugby so as to work out some good strategies. So the first one, diagnosis of dementia, and the idea is if we could diagnose dementia early on, then we could really save a lot of grief and a lot of money and get treatment going earlier and be more effective earlier. And this was done by two of our master's students with the support of experts in IBM research labs and also medical experts who are experts in the area. This is part of a process of an area called multi-criteria decision making, where you define what the problem is, and it was done for a master's dissertation. So you have to get the scope of the problem, define it, and then identify something about the problem, the industry or the business or whatever it is, and see can you do something about it. We always bring in any expertise that we have. So it's about organizing the expertise that is there. And so you have to use the best expertise and try and build on that using a business process. In this case, it's an analytics process using multi-criteria decision making. One of the reasons for doing this, well, early diagnosis would help a lot, help families, help individuals, help maybe a stitch in time saves nine, so to speak. If you really get it early, you may be able to do a lot more good. So part of the process for doing this, and one of the reasons why I want to show this, is that in something like diagnosing dementia, the doctor is looking at the symptoms and trying to work out what they are and then how they fit into a structure. What we do in analytics is we do this kind of work. Generally, we've been doing it for business problems. So these are criteria. To doctors are symptoms, but for us are criteria which go into a business process. Why do we do it? We're doing it because we want to help make a decision. In this case, it's a multi-criteria decision, which is to differentiate dementia from similar alternatives so as to help the doctor make a good choice. Is the person suffering from depression or delirium, or is it dementia? And so multiple diagnostic criteria, conflicting alternatives, and building a criteria tree so as to carry out a multi-criteria decision. So applying multi-criteria decision making, what we do is we look at these criteria, or if you like symptoms, and we structure them into clusters using some of the structures that we have. And you can see there, one of them is convince me. It's a convincing structure. Convince me that the person has dementia. The convincing structure is relate to self, relate to others, and relate to world. So if you look at the three columns there, you can see that the medical people already would do that. Say, well, there are physical things, symptoms, and there are psychological symptoms, and there are social symptoms. So the symptoms that are there are the criteria, as I say, break down into those fairly well. At this point, we're not experts in the medical field, so you have to work with the experts. And these would be two students who were doing this. How do we break down this at the next level? Because what we're looking for is a criteria tree which could have 2 or 3 different levels. So at the top level, it seems to work that it's physical issues, psychological and social issues. Normally the way we would look at that is say, well, convince me about the physical issues, so maybe it's break those down into self, others and world as well, and psychological issues and so on. So you start out with a hypothesis that that is what it looks like. That's the structure that it seems to operate. And when you do that with that hypothesis, you then go back to the experts and see how they do it, and also the diagnostic methods. And we go through a process. Now, this is the whole process for multi-criteria decision making. So you're proposing what the structure might be, and then you're developing perceptions about it, and then pull is to actually start to use it, and push is to actually make the choices. Now, okay, it's a lot of complexity here. It's not necessary to follow all of these, but in the top right-hand corner, you're talking about getting access to the constructs and using psychological approaches like personal construct theory. You're asking people, well, you know, what is it, what is the issue, and then you've got a grounded theory type approaches where you're looking at procedures to differentiate the clusters into subclusters and so on, and then you're trying to work out what these are. And to relate them to a structure, and that's the critical realism one, is what is the actual structure of this criteria tree? And then nomology, my main field, which is really analysing to try and understand what the structure is and make some kind of sense of it, and then work on to do some scoring. Now, going around then onto the second half of the tree on the bottom, you've got the interaction one, is where you go back to the medical people or to the experts or to the clients, wherever it is, do some interaction and verify. Then after that, you do some scoring, some measurement, and that's what we'll be going to. And then you use software to do some differentiation of this, to try and eliminate some of the pure alternatives or clarify things, and then you build cases. So far what we've done is we've gone nearly through the first half of it. And then after that, we're going to do the scoring. And this is what we came up with as a prototype structure. We had a 3x3, except that when we went back to the medical people, they said, well, it doesn't really break down into 3 things at the physical level and the psychological and the other level. It actually breaks down into 4. So this is the tree that it ended up. And if we focus on it to make it a bit easier to see, for the first one, the physical factors, you see these are the 4, and I'm just going to enlarge them again a bit more, and you see what these are. So what you see then emerging is psychomotor activities, physical exam, medical history, and sleep patterns. These are the physical ones that the doctors actually look for. Now, this is what they actually do, but what we've been doing is putting them into a structure. What you see there in the middle with the 3 colors is that this actually becomes used with software as a scoring system to score the physical factors for each of these 3 alternatives, delirium, depression, or dementia. And the idea is that you score the individual who's being diagnosed on each of those 4 on the right, and then you get amalgamate those 3 into the scores of the 3 things, and so on upwards. This is the full diagnostic guidelines that would be used by the experts. And you can see that it's a table, somewhat similar to the table that we have, and I'm going to expand that to make it a bit easier to read. And you can see here you've got delirium, depression, and dementia, and the different ways that these are tested. And you can see on the left that corresponds to psychomotor activities. Now, so that's what they're rating against. That's what the expertise provides, and what we're doing is we're putting this into a form of a criteria structure. Now, we usually use criteria weights, how important are these different things, and we also use scoring of alternatives, 0 to 10 and stuff like that. Now, the weights of importance, actually the particular clients, in this case the medical people, didn't want to give precise weights. I mean, if there are 4 issues, we would say, well, surely it's a quarter, 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 and quarter. Those are the 4 weights. And they say, well, we don't like to give precise weights because we're not really sure. And also, we tend to give scores. 0, it isn't present at all. 10 is really, absolutely extremely present. They said they prefer to use a verbal scale from not present to present. So you have to adapt our approach, and as we did, to what they want. Then after that, we built a decision support system, which has those particular characteristics. And of course, you need a decision support system so as to make it usable, incorporating all those different things. And we then implemented with the usual things that you need so as to make this usable. But this is so that it could be rolled out into the HSE, and GPs could use it throughout Ireland. Well, as part of a dissertation, we then say, well, we want a contribution to business and society, and these are the contributions that you see. And also, we want an academic contribution. So the second case, it's an application to sport. And same sort of thing, but just showing the versatility of analytics. So this is the normal way that things work within sport. You can see you've got a lot of match event data being gathered by, in this case, by Optisports. And then you have various performance metrics, and then you've got expert evaluations, and then post-match analysis, and it goes around in a bit of a circle because they're feeding back to each other. But what we're interested in doing is synthesizing the expert users and the performance metrics and doing a learning process, a circular learning process, so we can actually go back and engage with it. It isn't just a case of, oh, this is what the data tells us, and that's what we better do, but we can actually tell the data, we can use software to do something more with it, and so as a learning process. So to do this, as in the dementia case, you need to build metrics, and what we call them here were hot performance indicators, HPIs, because when you look at a rugby game, and you're filming it, and then you're sort of making a note of all the different things and using software to break it down, and you're, distance the ball is carried, where is it on the pitch, and the speed, and who tackled and when, and how slow were they up to the gain line, all that sort of thing. You have to identify what are the really important ones and what are the less important ones, and how do they link these to each other. And of course, you've got the experts and who are going to feed into this. So we have multiple complexities with this, massive amounts of data. Everything has to be done well, technically, but also has to be successful, and also it varies in the context that if you're playing up against a really good team as against playing against a really bad team, well, you might really look very, very well against a bad team, but you collapse against a good team, and you need to be able to differentiate those things. So what we want at the end of this is to be able to use this to predict match outcomes, but it's not just that, because which might be used for some kind of gambling person or something like that. It is so it's to identify where are your strengths and weaknesses and what you need to do, and track them back to each other. So that's the question. Can we actually do this and apply our structures, our analytic structures? In this particular case, it is adjusting structure. Why the adjusting structure? Because it's objective. You have an objective winners and losers. You have to have a balanced team. You have to have a balanced game, and so on. And so part of this was to test this. Does this really work? Now, when we did this, part of what we do is we do a literature review. And, well, where is the literature? Well, actually, there's more literature on soccer than there is on rugby. So we went back and we found that there was a literature about soccer which said important things are possession, set pieces, distribution, and general execution, scoring and stuff like that. So we then went to the experts and asked them, does this really follow for rugby? And they said, yes and no. Yes, it follows that you need those things, possession, set pieces, distribution, and general execution, except that in rugby it's a bit more complicated. Why? Well, for instance, in set pieces, you've got scrums and lineouts. In ball possession, you've got ball carries and ball collections. So it actually breaks down into 8. Now, this was interesting for us because we have a structure of 2 by 2 by 2 of 8 things, and it does go up to 16 sometimes. So inherently, it seemed as if there was a structure that it seemed to be validated by this. So this made it more interesting to see, could this possibly be true? Anyway, to carry out the work properly, we now have to break the job down, which meant that we have to look at each of these 8 things separately. So we thought, well, we'll just look at one of them, and in this, for the purpose of this presentation, so let's look at tackles and see what's involved in tackles. And tackling, when you analyze it, and again you go into the experts, and then you look at the structure, you see that there are at least 3 major parts of tackling. There's the skill, the technique used in tackling, and then there is the appropriateness, depending on the opposition. If you are winning by, 4 points, and you've got 2 minutes to go, and you're fairly weak, but there's a very strong person coming down, thundering down on you, and you really have to win, you must tackle that person. And then making that tackle is really, really important. And the last one is the more situational ones. Did you want to get a better field position, or you want to score, or whatever? So a good tackle you want to see is good or convincing technically, and then the context of the game, and then the situation where you're trying to save a game or win a game or whatever. Within each of those, the technique, I want to be convinced that we've got a good technique. So things like the offload, not allowed, haven't conceded a penalty, completed the tackle. So subgroups of convince me that the tackle is good. So it's quite a lot of breaking it down, and quite a lot of information. And this is part of the thing about analytics, is that it's not just analysis, it's also technical, because you're using a lot of software and you're gathering things together from many different sources, databases from many games. So this is what we did. We got 80 match events and outcomes, and we started gathering the data from that point of view, using software that was built for the purpose to actually amalgamate all of those. And you can see the different parts that are there on the top side: complete attacks, forced into touch, missed, and so on. Doing well or doing badly, and so on. Having done that, then, because all of this is built into a success or failure evaluation, we see that we have score modifiers. So look at the left hand there. Part of the nature of score modifiers, you're the position that you're in, the quality of the opposition, the location on the pitch, and the home away or away disadvantage. Now, as part of analytics, we are combining business, as in practice, with the academic. So there will be theory in all of those, and therefore you analyze those to see how are they taken into account. And that's what was done. So it's to amalgamate those scores into an overall score. Then once you've got that, you then want to visualize the metrics. So you can see the top row is a graph, and it goes over 22 weeks. There are 3 teams: Aironi, an Italian team, Leinster, and Munster. And this was in the case where Leinster won out and Munster was just behind them, and Aroni didn't do well in the end. So what you see here is the average scores for those three teams over that period. And you can see, Aroni started well and then, and then finished badly. Leinster peaked very well and then dipped under Munster and then came up at the end. Look at the copper one below. In a way, that's more interesting, because what that does is it takes the scores and shows them in a structure. This is the structure of the 8 things that I talked about. And you can see ball collections, scrum, line out, hand passes, and so on. The scores, those shapes within that, further out is a high score, further in is a low score. So the team that is better is the one that has more further out. And you can see there's some overlaps. Now let's look at the particular interest for Leinster, which is the light blue. Do you see that in the line out, it actually is quite poor by comparison with the others? So one of the teach or tell a coach that if you were playing Leinster at that time, because they didn't have a Paul O'Connell, they didn't have high jumpers who could really take the ball well in the line out, you would play the wings and you'd have a better chance against them, even though they might be a better team. And of course, what we're talking about in applying analytics to sport is trying to help people to get the best out of their team, recognize their strengths and deficiencies, diminish the deficiencies and build on their strengths. So here are 2 tables summarizing the outcomes and predicted. The top one is the actual hot performance indicators versus the match outcomes, and the one below is the predicted versus the match outcomes. And so when you're actually doing it in terms of the hot performance indicators and that particular match, then you're going to see more of a correlation. But when you're doing about the predictor, it's talking about predicting for the next match. And you can see that the top one is about 75% accurate, which is pretty good. It means that the predictors from the hot performance indicators told you pretty well 75% sure who was going to win that particular match. The other one, the one below, it gave you a sort of a 2/3 probability that you would get it right, which is better than what would have been there before. So that's the business contribution. The academic contribution is that we actually have verified the structure. And so we've got the possession, set pieces, ball distribution and execution as we had before. But now we can see how that breaks down into ball carries, ball collections, scrum and line out, and so on. What is this useful for? It's useful for coaching, because when a coach is trying to build a team and bring a team on, he has to take account not only of all of these things individually, but of the balance between them. Because if you got 7 out of the 8 things really, really good, but the 8th one was really awful, you're going to have such a weakness that no matter how good you are in all the others, you're going to be in trouble. And if you find that you're quite a serious imbalance, for instance, your set pieces are really bad, you can't win matches. If when it comes to scrums and lineouts, you're not going to be able to succeed. Or maybe you're very good in the first 3 quadrants, but you can't actually execute. So you win everything except scores and matches. So these are 2 illustrations of analytics which can enable business strategy, and they show the application from the medical area in diagnosing dementia to the sports area in helping coaches with rugby. Thank you.